As I was saying, hello everyone, hello to all of our regulars and hello to everyone that is joining for the first time. We hope that you find this meeting useful. The goal of these regular meetings that we are having every month is to give you some updates on how the community is behaving, any new things that we're implementing for open metadata, as well as giving you some webinars, some dive deep demos into some specific topics. If you have any questions, feel free to use the chat. Okay, we have other people here, Teddy, Harsha, that will be able to give a hand while we go, and we'll try to make sure that we have some time at the end to keep discussing in any topics that you would like to talk with us about. But today, before we go on, there's something very important that we'd like to tell you, and it's not that I learned how to use GIFs in these slides, is that we really appreciate your feedback, right? So there are two ways right now that you could really help us out. The first one is if you have some ideas on how we can improve the UI, you have been playing with the tool, you have like some thoughts on maybe if we change this button, if we change this screen, if we move the user experience somewhat, please do let us know. Okay, you can reach out to us. We can schedule a 30-minute call, and we would really appreciate your feedback in order for us to grow the project together. And also, I'm sure that all of you here already know Shilpa. She's awesome, putting all of the announcements in Slack, and she recently sent a survey where we are trying to get some inputs on what is the status on the community in their journey in using open metadata. So if you could put a couple of minutes aside to respond to that and also to give any other feedback to us, that would be really, really awesome. So thanks a lot. Keep rocking it out. And we are always here to listen to you and to help out. That being said, another important thing for today, another special day, is that today is actually the first community meeting that we have some community spotlight. And in this case, we have Cristian, he's a staff software engineer at Forter, and I am not only excited to have him here to talk about how they are using actually open metadata at Forter. We are also super excited because he has been really, really helpful in implementing the new storage services in open metadata. Don't know, for those of you that have already been to our last community meeting, we discussed that we are going to be introducing a new way of handling S3 buckets, the objects, partition tables, and so on. So Cristian has been working a lot with us in order to make that a reality. So thanks again, Cristian. Really, really appreciate the effort. And we'll have him here today also to help us with the demo, which is more than awesome.
Thank you. Thank you. And it's very good to be here. And thanks for the kind words.
Awesome. And then for those of you that don't know me, my name is Pere, and I'm part of the founding engineer at Collate. You might have seen me on the Slack support channel. If you need anything, feel free to reach out. Now, let's talk some numbers before we jump into the action. The community keeps growing more and more. We are already at 155 open source developers, and the next one could be you. So don't be shy. Let's make sure that we keep bumping those numbers. It's always awesome to get new PRs, new contributions for the community. The GitHub stars keep growing. I was actually checking today, and we are already at 2,080. So I think that we changed that at yesterday or 2 days ago. So it's awesome to see how these GitHub stars keep growing day after day. We are already at 2,600 members in Slack. So this is more than awesome. We love to see all of your questions, all of your feedback, all of your feature requests. So don't hesitate to join in there if you are not there, because that's the best and easiest way where you can get in touch with us and with the rest of the community. And together with the rest of the social platforms, we are at more than 1,200 community members. So thanks to all of you that are following us, that are interacting with us, and that are helping us into making open metadata better and better every day. Community spotlight, community contributions. This is maybe one of my favorite slides here. So as you can see, this last month we had 3, 6, 9, we had 10 contributions from different people. Also, Shlamiel here has been doing an awesome job into keep improving and improving and improving the Python SDK. So if you have an issue that maybe you open something that it's bugging you that you would like to fix and you want to actually fix that, but maybe need some help, do reach out to us. We're more than happy to get you quick started on that aspect. And also if there's something that it's bugging you, but that maybe there's not an issue yet, you can also go propose the changes and we can make sure that all of these things are landing if they benefit the rest of the community. So thank you very much to all of these contributions. And we do not only appreciate PRs. If you have any issues, any other feedback, please don't hesitate to get it reached to us. Now, some numbers in terms of how we are doing in the project and how we are doing in Slack. So our number of merged PRs per week, so you can see we even closed the 100 PRs a few weeks ago, and we are at a very, very stable, more than 50 PRs per week. So as you can see, the team is very, very busy into making sure that we are putting all of the right features and the right fixes for you for the 1.0 release. And in terms of the activity in the support channel, we got 358 total support questions in the last 4 weeks. Here I'm just showing a bit more, but just in the last month, we got more than 350 questions, and our team usually responds in 9 minutes or less, which is an awesome job that we are doing here to try to make sure that all of you are succeeding with OpenMetadata. And for those that are already veterans in the project, that you have been following us since release the 3.0, 4.0, 5.0, and you know how things work, if you think that you can also help and contribute for the rest of the community, we would be super, super grateful to also see you active on these channels. And finally, some roadmap highlights, summary or review, because I think that we already shared this slide on the last month, but just for those of you that maybe weren't there in that time, we are bringing a lot of new and interesting things for the 1.0 release. In the terms of the UI and in the user experience, we're improving the lineage performance. Now it's going to support thousands of nodes without freezing absolutely anything. So for those that have huge data platforms with a lot of dependencies in there, you should have all of your issues solved with this. We're also working very, very hard with other community members into bringing the localization into OpenMetadata. We're working to have Japanese, we're working to have Portuguese, we're also working to have Spanish. So if some of you would like to chip in and make sure that it's not only ChatGPT and us trying to put those JSONs up in place, also do reach out to us and we will really appreciate your contributions in that. We are going to keep improving on the alerts notification in the user experience and on the overall documentation of the platform. And on the side of the ingestion, we are going to improve, actually we already improved the login results of the workflows to make sure that it's easier and easier all the time to just go debug and understand what's going on. We are bringing out automatic PII tagging based on the NLP and regex on your columns and on your sample data. This brand new S3 ingestion that we're going to be showing you in just a few more minutes. And we are also bringing out the dashboard models for sources such as Looker or such as Tableau, so that you can keep gaining more and more understanding on what is your data on the maybe more business side of things. In terms of schedules, we already have the alpha release. It's ready, it's done. You can just go on, get the binaries and start testing out. Something that we cannot just stress enough is that please, please, please do not upgrade your production environments with these releases. or any other environments on that matter, right? This alpha release is still a bit rough on the edges, so please just run this in isolation. It doesn't matter if it's on bare metal or if it's on Docker or any flavor that you like the most when running the open metadata distribution, but just make sure that you are putting it in some place new or someplace clean. Then in terms of the 1.0 release, this is where we're going to put all the time that we have in order to properly test the features, properly test especially the upgrades, because we want to make sure that your journey from the 0.13 into the 1.0 is as easy as possible. And for now, our tentative date would be the week of the 17th of April. And now just a few words from Cristian before we move on. So thank you.
Thank you, Pere. I want to first start before diving in about Forter and myself. What I want to point out is just a few things about the experience of working with the open metadata folks. So, of course, we had a requirement of getting S3 metadata functionality into the product. We've approached open metadata people, and we had a very good experience in terms of working with them, speccing out what we need, what the community needs, trying to get to a compromise in terms of what can be delivered, timelines. It was a very nice experience, and I think it's very encouraging to see so many people contributing, and I'm sure everyone that has contributed and has interacted with these guys can confirm it's a very solid product, and I hope it keeps going on and it keeps growing. It helped us a lot, and I just wanted to stress this out. Right. So I'm Cristian. I'm coming from Forter. Forter is a fraud prevention company. They work with a lot of US large merchants which have fraud prevention needs. So you can imagine the company has many data stores across a variety of types of data stores, be it data warehouses like Snowflake, RDS, relational databases, a lot of data on S3. So of course, we looked at open metadata as a potential product to get to catalog all this data. We did look at other alternatives, but in the end, we liked the flexibility of the product, the fact that you can, of course, chip in and help, being an open source offering, and it just felt more mature than other things that we've seen on the market. So we are using it live at the moment with Kubernetes deployment, and we're slowly building our catalog. Of course, we're using some other features as well. PII tagging. We can't wait for the auto classification feature that will come in the next release. And of course, everything that has to do with connecting the dots and connecting different metadata from different places. We want to use the catalog as a centralized location for everything. So we're slowly getting into that. Next slide.
Awesome. So, well, thank you, Cristian, for your words. As you can see, we don't bite. So we are more than happy to work with any of you. So yeah, thank you very much. I'm super happy that you are able to at least fill in these gaps with open metadata. We love to hear this feedback, and we love it even more when you are missing something and you come here and you do it. So that's even great. And that being said, let's jump into this webinar on the storage services. And in order to fully understand why we did what we did, let's give some brief history on what is already there and what has been, or how has that been received from the community. So our current Datalake connector, it's already there. You can run it on top of S3, you can run it on Azure, you can run it on GCS, and this is part of the database services, meaning that we are going to ingest the data that we get from these cloud storages as tables. And how currently this works is by ingesting the files, for example, in S3 from the buckets as individual tables. And this might be good for some specific use cases where we want to profile all of the tables. We don't really know what's in there, so we want to get all of these schemas. We want to make sure that we're getting as many insights as possible. We want to run tests based on our packets, on our arrows, on our JSONs, right? We want to really make sure that we get as much information of everything that we have in those buckets or on some of the paths of those buckets. But that's not the full reality when we're talking about data lakes, right? A lot of the feedback that we received from this data lake connector is that it might not always properly represent the structure of the data lakes in different companies. Some of the questions that we had in there is, okay, instead of ingesting the files as individual tables, what can we do? To say, for example, you have one table that comes from Spark and it creates 10 parquets. Why do I need to ingest the 10 individual parquets if I have only one single logical table? Or the same thing can be also argued if instead of 10 parquets, we're talking about thousands because we have a partition table by date, by field, by anything that we might have in there. By why do we need to always go into the individual tables? And based on this initial idea, and thanks to all this feedback, that's basically what gave us the trigger to explore other alternatives on how we can actually represent these different structures that cloud containers or file systems can actually be giving to us. So the data lake connector will still remain as is. And what we have built right now is another type of services, the storage services, which has its own internal structure, which we are calling it as a container. And the idea, our thought process when we start building any new entity is that it should be generic enough to represent any storage service. So right now in this example, we're going to talk about packets, we're going to talk about S3, but in the end, we need something that we can apply to any other service. It should be able, we should be able to apply it on Azure, we should be able to apply it on GCP, and we should eventually be able to apply it on any physical NFS that we might have also on our own premises, or any other file system like service where we might want to get some insights on what type of data do we have in there. Is that data structured or not? What are the formats? What's the size? What's the number of objects that we have in there? So there are many different questions that we might want to ask on top of that metadata. And the actual model that we built here for our open metadata standard is based on a single structure that we are calling the container. So these containers are the children of the storage services. And in there, we are going to find properties, the same that we were discussing, right? The size, the number of objects, the formats of the files, and an optional property might be the data model. Do I have something here where I can extract a schema, or it's just random GIFs, MT4s, or data like that? But what is interesting about this container entity is that one container may have a parent, which is another container. So bit by bit, we can keep building a tree structure that is going to represent the files, the entities that we have in our storage systems. To give you an example on how this looks like, let's suppose that I have this full path on an S3 bucket. I have the bucket, directory 1, and directory 2. So the bucket would be a container, but it would be the root container. It has no parent. It just lives inside the storage service. Then we can have the directory 1, which would be yet another container, but will belong inside my bucket, and then the directory 2, which would be again its own independent container, but living inside the directory 1. So as you can see, bit by bit, this structure is generic enough for us to keep adding all the different pieces that we need. And at each of the steps, we can answer the questions. What's the size? What are the objects? Do I have any schema here that I would like to surface in the UI and to analyze and extract any further information from here? Then how we are implementing this in S3 is that by default, we're just going to go in there, we're going to scan your S3 buckets, we're going to get a lot of high-level metrics that Cristian is going to dive a bit deeper on that. But still, we have the main question that is, how do we handle structured data versus unstructured data, right? That's basically how all of this conversation was born when we started to analyze the data lakes. How do we make sure that we can understand somehow if this is partitioned, if this is not partitioned? How do I need to treat if I have a bunch of CSVs and parquets and TSVs and JSONs together? And for this part of the explanation, I'm just going to pass the word to Cristian.
Cool, thanks, Pere. So yes, so in terms of the model, you've seen the details. You've seen that the model is smart enough to support a hierarchy. It's smart enough to have a parent and children relationship. What we needed in the first place was actually quite simple. We wanted to auto-discover many S3 buckets that contains both structured and unstructured data. So the existing data lake, as Pere mentioned already, wasn't really a good fit for us because it creates a table for each file. Some of our buckets have millions and billions of files, so that was just not feasible. So obviously there are a few trade-offs that we had to do when we thought about implementing this. Some of them are performance related. So for example, how do you infer schema definitions from millions of files? How do you compute size and number of objects within buckets that have many files? And how do you know which path contains structured data or doesn't contain structured data? So to do all this, we went ahead and made a few assumptions, and we also try to have a simple approach first, a simple implementation on top of which we can build and iterate in the next versions. So what we did is we came up with a manifest file where we would put information about which path from a particular bucket we're interested in ingesting and whether this path contains structured and partitioned data. We'll have a look at how this manifest looks like in the demo. Yes, exactly. Definitely DBT was the inspiration for this. And we support Avro, JSON, Parquet, CSV files for the structured locations. And we can, in the next slide, we'll look at how can we, how can we look at some basic metrics for buckets in general, and how can we get them in a way that's efficient. So for example, a naive implementation for counting the number of objects and the size of the objects in the bucket would be to just go iterate over all of them, have some counters and compute them. Of course, you can do this with millions of objects in a bucket. You cannot list them. It's just way too many of them. So for these two metrics, a more effective way was to look at CloudWatch metrics. These two, the total number of objects and size, are actually computed on their side, so server side for each S3 bucket. So we thought this might be a better alternative. You need specific permissions to be able to access those, and they aren't 100% accurate, as in they are recomputed, I think, every day, or that's configurable. Still, having something approximately right is much more costly, is much more cost effective than doing an iteration over all the objects. Okay, so how do we do the sampling and the actual fetching of the metadata? We load the template file, we scan all the paths, and we see if the data is structured. We will sample one file and just infer the schema, similar with how you would do it from a database table. If it's partitioned, then you will have to define what the partition key is, and then the sampling will just go in one of the partitions, pick one file, and infer the schema from there. If the data is not structured, then the bucket as a whole can be ingested with the cloud metrics computed, but you won't have any structure. This was actually one of our use cases as well, because we also wanted all our S3 buckets to be ingested as entities in open metadata. This was because we wanted people to be able to tag them, to add descriptions to them and other external metadata, even if there is no structure to be computed, because maybe the bucket contains all sorts of unstructured files. Cool. So now I guess off to the demo. Let me share my screen. Okay, and let me know if it's visible. I'm a bit more of a, so I'm a bit of a command line console guy, so I'll be using this today. What I want to show you as a demo, I have the whole stack running locally, and I have two locations on S3. I'll just show you how they look like. So one contains transactions. I just have two CSV files there, and I'm just going to show you how one of the files look like. It's a very simple sort of generic file with two columns. I just have a transaction ideas and a transaction value. It's a very simple use case. I have another path, which is cities. This is a public data store, which I got from the internet, and it contains US cities. These files are partitioned Parquet files based on the state. So the state is the partition key in this case, and we can see that the file itself, the files, just to show you that. Sorry, there is a Parquet file here indeed. So this is the data, right? Now, how does my manifest file look like? This is an open metadata file, a JSON file, which I'm placing at the root of the bucket, and it contains information about what I want to ingest. It has two entries, one for each of the files.
Sorry to interrupt. Can you increase the font? I think it's a bit small.
Sorry about that. Let me.
No, thanks.
Is this better?
Yeah, looks good to me. Thank you.
Okay, sorry about that. Let me just. Right. So, as I was saying, I have two entries, one for each of the paths. The transactions one, I'm saying the path in the bucket is called transactions. It's it contains structured data in CSV files, but it's not partitioned. And the same can be said about Parquet files, with the distinction that here I have to pass a partition column, which is the state. So this is the data that I have. I have my open metadata stack running locally. What I will do is I will use a YAML configuration to ingest this. This can be done exactly the same way by going to the UI, creating a service, and adding an ingestion setup. It's essentially the same thing. I just want to save a bit of time of clicking and going here and there. So I will just run my ingestion directly from my IDE. What I'm saying here is I want to include only this bucket, so that only because of course we've got other buckets there. This is the only one that I want to look at. So I'll just run this. This again will do exactly the same thing as the UI. We can actually see from the logs that it picked transaction _2 CSV to infer the schema, and it picked one random Parquet file to get the schema from the Parquet path. So now if I go back to my UI and I go log in and I get rid of all the and then I go to containers. You can see I have 2 containers here. So for transactions, you can see the transaction ID and transaction value. And for the cities, this has a bit more. As I've said, this is a data set about US cities, latitude, longitude, whatever other information. You can see I already have an S3 or an object storage service created because of that ingestion. The same thing you can do by going and adding a new service and filling in the whole required configuration. I've just done it from the command line itself. Yeah, I guess one other thing, you can see number of objects and size. This is obviously, this contains all the files in the bucket. This is a test bucket. It has a lot of stuff inside. So this is why you see so many things there. But what we're interested really here is we have the structure that was inferred by sampling one file, and we have the template file that was loaded from the root path of the folder. Now, one thing that we do want to improve in the next iteration, as you've noticed, my template file, my JSON file is placed at the root of the bucket. This, at the moment, you would have to place this in all the buckets that you would be interested in loading. In the next iteration, we plan to change this approach, and we'll have a single file that you will upload, and it will contain paths, not just relative to a specific bucket, but you will have full paths here that can vary across different buckets. So you'd have one single file where you define everything that you want to ingest, and the service will take care of it. I think this is all I wanted to show you at this stage. I don't know, Pere, if we should take questions about what I've just shown, or
actually there's a question from Carl that he's asking, how does the date partition look like in the manifest if we have like year and month and day and hour, for example, instead of just one single level of partition?
So the partition key is, we use that especially at the sampling stage, right? Because we want to get, like, why do we need the partition key? We just need it to be able to compute a prefix of paths that we can go and look at files. So if you have a partition that has multiple components, if you pass the first one, say the year, that's already enough, because the service is smart enough to compute all the paths that derive from the first part of the partition, and then it goes into scanning mode until it hits one particular file with the correct extension. That's the only place where we actually need the partition to be able to search, to be able to know where we search for sample files, so that we can infer the schema.
So it's more like a partition pattern, right?
Yes, exactly.
Yeah, I think I also plus one what Suresh said. It would be good to have both bucket level as well as across the buckets manifest file rather than one single.
Yes, it's this, and we didn't have time to complete the feature by this demo.
The next iteration, I meant.
Yes, it's definitely something. So we started with this, and we've noticed after that hey, this will be way too cumbersome to keep putting files in every bucket, and it just won't work when you have hundreds of them. But we will change it very soon. Okay.
Awesome. Thank you, Cristian. So, well, as you can see, there are great engineers at Forter, which made the manifest handling very smart. And yeah, awesome work from Cristian. He did not only do the ingestion, he was there helping from the beginning, from preparing the JSON schema to even before, right? Actually figuring out the problem, discussing through the solution, preparing the APIs, the backend, how we handle the database. So a bunch of logic that Cristian was able to manage. And one thing that I also wanted to show here before we move forward. So Cristian has actually shown, okay, we can do all of these ingestions directly from our CLI using a YAML. And this is actually one of the main features, main foundations of OpenMetadata, which is that everything in OpenMetadata is based on API calls, right? And this means that these API calls can be run from absolutely anywhere. So it doesn't really matter if you run the ingestion using our Python packages locally, using a random scheduler, or directly from the OpenMetadata UI, the end result that you're going to have it's always going to be the same. And we're able to ensure that because everything is centralized via this API, all of the logic is centralized in the server, and absolutely any action that you see us making here in the UI, creating, deleting, adding names, updating, all of these things can also be automated. And this brings a lot of flexibility, because if there are teams that they are not as engineer-based as Cristian here, you can go, you can maintain and update and handle all the life cycle of your metadata directly from the UI. But if there are also engineering teams that they just prefer to have their documentation, their handling in their own ETL processes, because, well, they know from which tables we are reading, they know which tables they are writing. Basically, they have the source of truth in the code. In that case, they can also use their own ETL processes to extract parts of this information and send it directly into OpenMetadata. And that being said, I just wanted to show you here how this process would look like. So from the UI, this would be kind of my landing page here. And I can go into settings. From the settings, in this case, you can see my object stores. And I can just add a new connector to S3. This page is what we have currently on main. We are making this documentation much cooler than it is right now. And whenever I configure my service, I can just add any of this information required here, right? I can pass the keys, the secrets, the regions, and anything that is required depending on the service to be able to connect in there. And once we have the service already created, we can just go into the ingestion tab, add a new metadata ingestion. And in this case, Cristian was saying, hey, I can filter by containers, I can add this, I can exclude that. So all of these experience will be exactly the same from here. So I could just add or exclude any containers that I like, click on next, prepare the schedule, and deploy. And how this would look like would be exactly like this. As you can see, I messed up my environment in the first run, but I was able to clean it up afterwards. And then this same ingestion process, you can completely manage it from here. All the life cycle of your ingestion, you can do that only from the UI, so you don't need to jump into any external services. The idea is to make it this as easy and as transparent for all the users as possible. And
Can you show the logs?
Yeah, I can show the logs.
Actually pretty cool.
Yeah, you see all the logs here. Now everything is clean, 100% of success. And this we have also improved a lot. If something is failing right now, we would see a nice formatted table at the end saying, hey, this asset has failed with this exception. This is this tag trace to keep improving the experience of users and developers alike. And yeah, the idea is that I can see exactly the same things here in the containers minus the objects and the bytes, because I just created the bucket and my CloudWatch metrics weren't still computed, but as you can see, the exact same result. I can actually see it there. So that would be it for the demo. Now, in terms of the next steps, where do we still want to land this feature? First thing, we'll be supporting other storage services right now. For the 1.0, we're just going to release it for S3, so you can go, you can test it out, you can give us all the feedback, make sure that we keep improving that, and that we can also knock on Cristian doors again to get his help if we need something extra to be handled. Just kidding, a bit. And yeah, we want to support other storage services. We also want to add profiling capabilities. And we had a very interesting question here in the channel that it's this third point in the list that people were saying, hey, but how can we then treat the schema of a container if that happens to a table and so on? So we want to make sure that we put the logic and the thinking on how we can reconcile the actual table asset, maybe a table, an external table in Redshift, a table in Athena, anything that is managed in Glue, whatever you have in your Spark Metastore, together with its storage location. So we'll need to understand and dive deep a bit better in here on what would be the best way of actually linking these two same faces, these two lens of the scene reality. But this, we believe that it's also something that will be very, very important, very, very interesting for you folks to analyze. Okay, what's my table metadata and how this gets translated into our storage systems. So that would be it for us for today.
So Pere, a few questions are there.
Oh, a few questions.
Yeah, first question is, what does FQN look like for this new S3 container?
So the FQN, we are basically appending levels, right? So if I go, the FQN in this case, it would be my bucket.directory1.directory2. For the red one, my bucket.directory1. For the blue one, or my bucket for the green one.
It's prefixed with the service name, right?
Yeah, always with the service name before.
Yeah.
Yeah, I'm not sure, Austin, your question is, hey, Pere, I noticed that OpenMetadata uses AWS. I'm not very familiar using AWS. Why is... No, we are just adding AWS support. We'll add support for other things as well.
Exactly.
The next question, I think, Pere, you can see this yourself.
Yeah. So how will find by name work against the FQN? So this will be the exact same experience, like the API looks exactly the same as with any other entities. So you can just pass the full FQN if you want to access directly this specific entity at the depth that you might already know. The other thing here is that we have prepared the list API and the properties of the containers in a way that you can basically traverse the tree. So mainly you can start by listing the containers that are at the root level. That's a filter parameter on the list API to, in this case, that would just give you the my bucket. And then whenever you're getting the my bucket, you can ask this piece of data with its children. So basically you can keep jumping from bucket to bucket in order for you to traverse the full tree of containers.
So there's a question before that. Amazon S3 inventory provides, that's how it starts, with comma separated values, CSV, right? Apache optimize row columnar ORC and Apache Parquet output files that list your objects and their corresponding metadata on a daily, weekly basis for an S3 bucket or a shared prefix. So I think this is a fairly long question. I think you should read it in your mind and answer it.
Yeah.
I think this is if I understand it correctly, this is an alternative of to the CloudWatch metrics that we use. So it looks like this S3 inventory list would provide something similar, but you could do it at paths level. So you could prefix it by paths and get information about the objects inside. To be honest, I haven't looked into this. If this is something that we could use.
Yeah, so that's FYI from Zeni.
Mm-hmm. Thank you so much. I didn't know about that. We should have a look at this. And
yeah, that's actually a cool idea, because the metrics, we only support them at bucket level. So
exactly.
we can use this to whenever we are preparing our inside containers, if we can also kind of add the salt and pepper with this S3 inventory, that would be pretty cool too.
Yeah.
Apparently the customer need to pay it.
Oh, well, you need to pay for everything today. So,
the question from Carl: how will find by name work against the FQN? Asking because our Airflow lineage has bucket name, pipeline, and table.
So this FQN, I think that we already covered that one. This will be the same.
It's the same thing, right? Find by name works using the FQN.
Mm-hmm.
That is, FQN of a storage service or a buck container.
Yeah, exactly. It will be exactly the same. So you can just build the FQN at the level that, in this case, your lineage makes sense, and that would generate the lineage as with any other entity.
Maybe I can just try and clarify a little bit. Right. So what we have is just the bucket name, but not necessarily the full path coming out of the pipeline lineage metadata that's being put into the Airflow serialized bucket. So currently we've hacked our DAG code to store a manufactured fake database, s3.default.bucket name, and we use the script to create the fake database structure right now, with the S3 default being a variable that we can pass in and change if we needed to. And we did that because of the same kind of challenge with we have hundreds of thousands of files. But like 60, right now we have like 60 buckets that we're ingesting data from. And then that pipeline then puts it to a table. And we know all of the output tables. So the serialized DAG information for the Airflow lineage has pipeline on the left side, and then a list of tables on the right side. But it's, I'm just trying to understand then what information that I'm going to have to put in that out of the DAG to serialize DAG for it to ingest the lineage information for the Airflow. Then it'll link the S3 using this new container system to the tables, because when it searches for tables, it searches by name, right?
Yeah, so here it would be exactly the same, right? So instead of passing the FQN of your service default bucket. So this kind of dummy table that you're creating to represent this. In this case, it would be storage.bucket. You might need to previously create that bucket as a structure, but the storage the name of the container would represent a top level container, which in S3 terms, this means basically an S3 bucket. And for that, if you are using the Airflow lineage backend or the Airflow metadata ingestion, this is actually something that we'll need to also change to make sure, because right now we are only looking for tables. So we'll need to do a small tweak in the code to actually make it generic for any other kind of entity. So right now you need to put table dot and the, well, not dot, column, the name of your table. So we'll need to make something like container column, the name of your container, or any other entity that you might be also moving with your Airflow pipelines.
Okay, thank you.
Awesome, thanks. More questions? We still have time, folks. It can either be questions about this, or you can also ask open metadata questions to Cristian, how he's using that, what he likes, what he doesn't like. You can put him on a tight spot if you want. It's a very good opportunity. He's being recorded, so he needs to keep it cool.
I guess as a new person here, how do I get started with open metadata? It's well, it's my first time here, and I'm unsure what's going on, to be honest.
I would start with the sandbox. If you have not seen what open metadata looks like, play around with sandbox, and then slowly, gently, get a setup going on your laptop. Connect to some of your data sources you might have. Do you have some data sources that you can connect to in your company?
No, I'm actually still a student here. I'm still trying to learn. I'm still pretty young. I don't really know too much about industry and much about this. I just want to try something new and look into what open metadata is.
We'll send you some information. Drop us a line. We'll send you some information that will gently introduce you into, the data space and what problem we are trying to solve. Send an email to me at here. I'll send you some information to get you started.
All right.
Awesome, thank you. Here we have another question that says that object storage service is not available in the sandbox. Not yet, because the sandbox is on 0.13.2. I may think we should update this to 0.13.3. And the object store, like right now, we're actually doing the demo on main because we are that brave that everything would work. So we did it on main, and slight older version, so with not all the features ready on the UI, is also there with alpha. So you might not be able to prepare the ingestion directly from the UI, but it should work using the YAMLs and the Python's SDKs directly. And another question here is just going to stop sharing this way, I will see you better. Any updates on a JSON connector so that we can ingest metadata from systems without requiring admin access? Example, Power BI or Tableau. So Power BI, we have either we are finished or we are about to finish the implementation with slight changes on the connector code and how we are doing the API calls in order to not require all that service account with too many privileges and so on. We'll need to also iterate that for Tableau. So these kinds of fine tunings are something that we would like to give as much as possible as something native from our connectors, right? Instead of asking the users to dump the data externally into some JSON files with whatever structure and then bringing that into open metadata. In any case, this is also something that you can already do today using the custom connectors. So if the solutions that we're bringing here to relax a bit the requirements in some of the services, or maybe we have done it for Power BI, but you might still need it for Tableau. Creating a custom connector that it's just reading the JSON and sending that into open metadata would also be an alternative here to centralize all the information.
Harsha, there was a issue created by Vitali, right, on Tableau stuff.
Yeah, we already have that.
You know, we should post that here for people who are interested, where we can collect richer metadata from Power BI and other kinds of, you know, dashboard solutions, and people can come and provide input to us, maybe even specs to us. That will help us. I don't know if you have access to it.
Posting.
If we store a Python script on S3, how we can retrieve metadata of this script? And how can we represent the script on open metadata? So the concept of script is not yet a supported entity in open metadata. So we are right now maybe focusing a bit
think
more.
we can model after script as a pipeline, but S3 extraction doesn't support the as is. We're not looking at S3 buckets for storing storage of pipelines. Pipelines for us is more of a scheduler is there that is running in a scheduled time, frequently or whatnot. So you must be using some sort of scheduler to use this S3 script to run, right? So is it Airflow or some other mechanism? That'll be good to know.
By the way, you guys can unmute and talk. We don't need to.
Yeah.
Cristian told you that we don't bite, and even less via Zoom, so don't be shy.
I don't know if I'm pronouncing the name correct, Jaime. You might kind of explaining your architecture a little bit. How are you running that Python script on S3, and how do you kind of manifest that as a pipeline?
You might be on mute.
It's okay. We can take it offline.
So a quick question for you guys. How are you managing notebooks? Where do you store the notebooks today? You can answer, unmute, or type, you know, answers in the chat.
Maybe there are no data scientists here.
Yeah,
at least one.
Hey, we are getting bored of hearing each other talk. Please open up yourself.
So in our company, we use Git, but in the background, it mirrors the data onto an S3 bucket, and from there it's picked up into Airflow, and we use Papermill to run the notebooks.
I see. Yeah, no, there is the reason why I ask it is now we have S3 integration. There's a lot of people have asked for supporting notebook. Where do we pick up notebook from, right? So just collecting some information now that you guys are on the call. Pere, shall we wrap up?
Let's call it a day then. It's already 4 minutes past. So thank you very much for being here. Thanks a lot again to Cristian. Let's keep working together on making sure that we put the cherry on top of the storage service. If you have any questions, you know where to reach us, and we're going to save these and upload it to YouTube, the community meeting, and the webinar, so that we don't lose any of this information. And yeah, thank you again, and have a great rest of your day.
Thank you.
Bye, folks.
Bye.
Thanks, Christian.
Thank
Awesome
you.
work.
Thank you,
you.
everyone.
Everyone.
Bye.